Hello everyone! Welcome again to Sugilanon channel, The Unveiling Story and Sparking Joy. Well, today I'm going to upload a video regarding with my niche. One of my niche which is to do lectures and specifically in the subject of chemistry. Well, today is the first week of our class and the first semester for STEM student is composed of 10 weeks. So week 1 is entitled Matter and its Property. Okay? So this is your presenter, Rafael Padla Inson. Okay? So let's begin with. So in the context of property that's matter, we'll have to define first what is a property. So that is in chemical term, or that is a simply what we call a quality or attributes, or what you call this one, yung attribute as a person, yung kasanayan mo, di ba? So actually, property is composed of extensive and intensive property, and also it is also a property of a physical property or chemical property. All right. So in describing matter, properties used to describe matter can be classified as extensive or intensive property. Okay, so to define extensive property, it depends on the amount of matter in the sample. So take note, amount of matter. It could either be in the form of mass and volume. So mass is of an object is a measure of the amount of matter which the object contain, while the volume of an object is a measure of the space occupied by the object. So mass and volume is definitely an extensive property because it does really matter with these two distinct property. Well, extensive property, aside from the mass and volume, is another example for that is the length, the weight, and of course, as what I said, volume. So, say for example, the mass of water in 100 gram is really different from the mass of water contained in a 10 gram. So that's an extensive property. It really matter how much maliit or malaking bagay or big or small. So magmatter talaga for an extensive property. And of course, the volume for 0.100 liter to 0.01 liter is really a big difference when it comes to extensive property. All right. But for the intensive property, it does really depend on the type of matter in the sample. So not in the amount of matter. For example, intensive property is the density, temperature, color, melting, and boiling point, and of course, the specific heat. So let's go back to another example. So as you can see here, the 100 gram of water compared to 10 gram of water is an extensive, but when it comes to their temperature, no matter how big or small, the temperature of the 100 gram of water at 25 degrees Celsius is the same at the 10 gram of water, which is in the intensive property, which is intensive, which is 25 degrees Celsius. So meaning to say the temperature of water really is an intensive property because it does not really matter how big or small, and also with the density. So the density is also an intensive property because the density of water in a 100 gram or 100 liter or zero point 0.1 liter is the same with the density of 0.01 liter. So bisan pag isa na siya ka baso or isa ka barrel, ang density na is equal lang, pareha lang. So it does really matter how many, how much. That is for intensive property. Okay? So let's go back. So intensive property is also another example is aside from the temperature and density is the color, the melting point, boiling point, and of course the specific heat. So, and also with the hardness of the bowling ball is an example of an intensive property. How the hardness, no? So, intensive yan mga ganyan. So, in identifying substances, every sample of a given substance has identical intensive property. For example, every sample of a pure water is a clear, odorless liquid at a temperature. At that temperature, it will boil 100 degrees Celsius and freeze at 0 degrees Celsius. So yes, as I said, no matter how small or big it is, the volume or the amount of it, so the intensive property is in temperature. Okay, it doesn't really matter. So this property for intensive properties, because they do not depend on how big and how small the sample is. So in identifying substances for the physical property, because the physical property can observe or measure without changing the substance composition. So take note with that one. Physical appearance only. For example, include are but not limited to density is a physical property, malleability, ductility, solubility, state, and thermal conductivity. So those are belong to the physical property. So for example, the perceptual property of some substances, say for example, for the neon in the form of gas, so its yung color, odor is, a color is all colorless. Ang iyang melting point is negative 248 and boiling point is negative 248. So no matter how big or small it is, when it comes to physical property, you have to observe there's no changes in its chemical or substance composition. Okay, so another that property that belongs to physical is the density and of course amount of mass in a given volume. And substance is always the same at a given pressure and temperature regardless of the size of the sample of the substance. Say, for example, the density of one substance is always different from the density of the another substance. Take note that a triangular method, no, density is equal to, or density equals mass divided by the volume. D is equal to mass over volume. So that's the formula of the density if you have to, just in case that you forget the formula. So practice. A bar of copper has a mass of 216 gram and a volume of 24 cubic centimeter. What is the density of that copper? So just simply use the working equation. D is equal to M over B, mass over volume. So 216 divided by 24, that's density of the certain bar of copper. So take note, the unit for the solid is always sometimes gram per cubic centimeter, and for the liquid, density of liquid is gram per ml, and for the gas, ang most likely unit is gram per liter. So having that unit, it would also tell you what state of matter you are trying to compute or trying to get. What is the density of copper? Yes, just using your calculator, you have to solve for that one. Of course, detailed work equation and of course the solution. So the volume of candy bar is 55 cubic centimeter and the mass of the candy bar is 70 gram. What is the density of candy bar? So compute, okay? Just please watch and try to compute that one, that example, because it will maybe come out during the quiz or in the long quiz or in the exam. So you just better watch the video fully, completely. So another practice, this one, ice cube has a volume of 36 cubic centimeter. If the ice cube has a mass of 33.2 gram, what is the density of the ice cube? It's a very simple calculation. This is just only a sort of review. What is the density of water? Okay, so still more practice having this one. Please grab your pen and paper, ball pen and calculator, and of course use to compute this problem, because this would really help you a lot. Okay, so that's my advice. Take my advice. And yet two more example. Okay, just take a pause and then copy the problem, transfer it to your notebook, solve it to your notebook, And then, yes, you will be rewarded if you have tried to solve this one because it would be easy to your part. I know that. Well, let's continue to the physical property. So malleability is also a physical property with ability to be pounded into thin sheets, no? Um, for example, aluminum can be rolled or pounded into sheets to make foil. So that's the property of the malleability, changes on its physical appearance, and the density, of course, ability to drawn or pulled into a wire, ductility rather. Okay, so that's how we are trying to identify the physical property. For ductility, for example, copper in wiring, soldering wires or joints. Yes, that's example of it. Physical property also is part of it is the solubility. And of course, when we say solubility, it's ability to dissolve in order in another substance. For example, you want to try to put a solid amount of NaCl into water. Once it is dissolved, that's there's a solubility of that one. No siyang solubility. Or sugar or salt dissolved in water is an example once for solubility. There are ways to increase solubility. Of course, sometimes if the solubility is very slow, well, you have to heat or make a warmer for that certain mixture or solution to make it more to the increase to make the to increase its solubility and grind or smash that certain powder because decreasing the surface area would increasing its solubility. Fine or small granulars more soluble compared to larger surface area, mga large crystals. And stir or mix is another way of increasing the solubility of a certain sample or mixture substance. Okay? And of course, the state of matter, the physical form which substance exists at room temperature, such as in the form of solid, liquid, and of course, gas is state of matter. I think the fourth state of matter is the plasma, right? It's a combination of what do you call it one? Gas and liquid. Thermal conductivity is also a physical property. Its ability to transfer thermal energy from one area to another. For example, for thermal conductivity is plastic foam is a pore of yes, yes, that's it. Example for thermal conductivity is the plastic foam, but plastics is a very poor conductor. So a hot drink won't burn your hand because it will not conduct the temperature inside the toaster or hot coils. Yes, that's more on physical property. Well, for the chemical property, as the property of matter that dissolves a substance based on the ability to change into new substance with different properties. Okay, so criteria for chemical property is the combustibility. And when there is combustion, automatic na siya ay chemical property. Flammability and reactivity. So kaning mga tulo ka criteria. When it comes to reactivity, it's either in the form of acids, bases, and oxidation. Well, once that keyword is mentioned, surely there is a reactivity takes place on that is belong to chemical property. Okay, and can be observed with your senses for the chemical property and are not easy to observe as physical properties like that. For example, flammability only when wood burn, no? So in my lecture, always mention on when there is burning, flammability takes place, then chemical changes of property is happening and combustibility only when firewood explode, no? Then, of course, for reactivity, only when iron oxidizes into rust. That's absolutely chemical properties. Well, a physical change, let's go back to that one, physical change. So those are the physical, chemical property and physical property. When it comes to their changes, is a state of their condition from what particular state of matter from solid, liquid to gas. For the physical change, a change that affects one or more physical properties of a substance. So meaning to say, if ang physical property would change from one or more into other form, then there is a physical change happening. Okay, affects one or more physical property. See, and physical change do not form new substance. Okay, so please remember with that, and can often be undone. Example: butter on counter can be placed back in refrigerator and there's no chemical change happening. You just melt, freeze, liquefy the batter, so it will go back to freeze na po siya. That's a physical change. Change of state. That's what you're going to remember when it comes to physical change. There is a change of state from solid to liquid, liquid to gas, gas to liquid, liquid to solid. That's a vice versa, and of course liquid to gas. That's for physical change. For chemical change, that occurs when one or more substance are changed into entirely new substance with different properties. No, meaning to say there's something changes of its chemical composition. From this form to another form, you have created something else, new substances. Um, Form new one upon reactions of those reactant, and of course cannot change back under normal conditions. So meaning to say, when there's a chemical changes, a normal condition upon evaporation, distillation, we just try to regain its condition or state, it will never be happen. Maybe it for not a normal condition, you have to underwent that with a reaction, it will go back, but normally it will not. So meaning to say, cannot change back under normal conditions, and some can be changed back to other chemical. Kung naap kay other chemical intervention para mabalik lang siya for chemical means. Okay? And of course, common example for chemical change is reactivity, meaning to say oxidation. There's a rusting happen of iron or on a bicycle or in a galvanized irons or sa atok or any form of iron, and there is a rusting takes place. That's chemical change. pH acids, base or turn into acid, acids turn into base. Effervescent tablet. And we say effervescent, there na physis will happening. So na bubbles, meaning kag effervescence. Pag na bubbles, meaning na chemical change. Okay, flammability, burnt wood, chemical change, combustibility, firewood, and for you to give a hint in order not to confuse among physical and chemical change, there are five signs of chemical change in which when you see and experience this sign, meaning to say that's a chemical change. First is the only sure way to know where has been chemical change is the observance of a new substance form when there is a chemicals reactions or takes place. Sometimes that is hard to do so for the science, so that's why it isn't enough to consider the changes of chemical reactions because you need another proof. So sign one for chemical change is the odor production. This is an odor far different from what it should smells like. So meaning to say, well, there is something change in the odor, rotting eggs, no? Kaya when you try to smell the eggs, not spoiled eggs, so no chemical reaction takes place when, but in the indication that is a rotten or a chemical changes takes place, the odor is changed and smells bad. Food fridge, no, and decomposing flesh. So those are the odor productions indication, dead decomposition, no? Dead bodies or flesh or meat, decomposition of other, etc., is a sign for a chemical change. And of course, change in temperature. So we have a lot of I have a lot of term to introduce to you, the exothermic. So there are two types of exothermic reactions, the endothermic and exothermic reaction. Exo means heat. Heat is liberated from the system, from your sample, going to the environment, that is exothermic. When or in heat is when in the form of energy. So when energy is released during the chemical change, example, wood is burning from the system going to the environment, that is exothermic. Again, when you say exothermic, exit, heat is liberated from the system going to the environment. Exo means na exit siya. And of course, endothermic energy is absorbed. Heat is absorbed, causing a decrease in temperature of the reactant materials. Example, cold pack in a first aid kit. Um, Bugnaw siya, pero once you put that into your forehead, no, when you have fever, muinit siya, and later on, it's because heat coming from your body ni transfer dito sa cold pack, no, kana ibutang sa agtang. Or during the daytime, kanang swimming pool, mo absorb siya heat from the environment. That's why when you try to submerge yourself in a swimming pool, you feel warm. Pero pag rainy season, since during daytime gi-absorb sa swimming pool ang heat, nga mas pag rain, mas cold ang temperature environment. So mas higher ang temperature ang nasa water during kay gi-absorb niya during sunny days. So you feel warm kung naka sa ilalim sa tubig compared sa outside sa swimming pool during rainy days. Okay? So changes in color is a sign of chemical change, but as I said, it's not really 100% reliable that you would say when there's a change in color all together considered na automatically chemical change na siya. No, because there are some cases that there is a change in color but there's no chemical changes happening in it. No, you have to make another sign or proof to identify aside from color. Example, fruit changing color when it ripens, leaves changing color in the autumn, or dying hair. That's a chemical change, no? For that certain, very obvious na siya. Again, ripening, rotten, no? Naglata or nasobra ka ripe, there's a chemical change. Leaves changing in color from green to yellowish, or when the leaves is dying. So there's a same chemical changes happening inside the leaves. And of course, you change your color. That the normal composition of your hair is not that normal, but there is something additional chemicals to your hair. That's why it would change its color, no? And straight into curl, you have to add the presence of sulfur, no? So there's a chemical change happening in that one. And formation of bubbles, ano siya, chemical change. This can indicate the presence of gas. Bubbles produced when boiling water is not chemical change. Sometimes, no? Take note, bubbles produced when boiling water is not a chemical change. But there are cases, most of the time, when there is a bubble, presence of gas, there's a chemical change due to a certain reaction. What the PowerPoint trying to say is for the pure water, when you try to boil that one, no chemical change because it's just only trying to escape those liquid into gas molecules without changing the real composition of water. So therefore, when there is a reactivity to the medium of water, then there's bubbles happening. For example, metal, alkalized metal, the height to form hydrogen gas, no? Butang nimo dito, i-react nimo siya sa kuan substances. Then there is a liberation of bubbles. Then of course, na chemical change. And of course, formation of precipitate. So formation of precipitate when two liquids combine and a solid is produced. Yes, solidify siya sa ilalim precipitate, that there is a chemical change happening. So those are the criteria for considering for chemical change. Excuse me. For the states of matter, let's have a review. There are three states of matter: the solid, the liquid, and of gas. Solid forms matter that has definite shape and volume. while liquid forms matter that has indefinite shape. It flows but definite volume. It really assume the shape of the container depending on the what kind of shape of your container. Then the liquid will assume that certain shape. Gas is a form of matter that takes both a shape and volume of its container. The gas state is the only state of matter that is compressible. No, you can compress that one. Solid, liquid are incompressible. No? Vapor describes a gas that is usually a liquid or solid at room temperature, as in water vapor. So that's the difference between gas and vapor. Again, the difference between gas and vapor. Ang vapor, gas is usually liquid or solid at room temperature, as in water vapor. So normally we cannot see it in our naked eyes. There are in the surface of the water, some of the water's liquid molecule try to escape into gaseous form. Vaporize ang term ano siya, at normal temperature, escape from liquid into gas. No, that's it. And solid particles among the three states of matter, it's very common, solid, liquid, and gas. Solid are tightly packed in a rigid structure. It has a fixed shape and volume. Liquid particles are very close that move around each other, takes the shape of its container but has a fixed volume. No, it assumes the shape of the volume. Well, since gas is are particularly very far apart from each other, they're randomly moving within the container. It has no fixed shape or definite volume. Okay, so try to imagine this is the atoms and molecules inside for the solid, liquid, and gas. Okay, and substance go from solid to liquid to gas as energy increases. So there are again commonly three states of matter: the solid, liquid, and gas. And then the fourth is the plasma. It's very high temperature, energy temperature for the plasma. No, sometimes gas and combination of other liquid, etc., considered as plasma. And for the states of matter, you can compare with this demonstration for the atoms and molecules. For the solid, very tightly packed, close to each other, um, than liquid, and for gases, very far away from each other. And we have a new term. Try to consider a phase. When you say phase, that is a region with homogeneous uniform properties, and conversion between states are called phase transition, either changes of states. Phase transition, transition from solid to liquid, liquid to gas, gas liquid, liquid to solid, just like that. And of course, in the mixture, we have two types of mixture: the homogeneous mixture and heterogeneous mixture. Of course, when we say heterogeneous mixture, ang iyang properties are not uniform, meaning to say the phases of matter are not uniform. There are two different phases of matter. There are solid or liquid, that's heterogeneous, or liquid and gas inside in it. There are two different mixtures or two different phases mo na siyang heterogeneous. And for the fixed composition, homogeneous means once you dissolve sodium chloride into water, and overall only one phase that you could observe, and that is homogeneous mixture, meaning to say one state of matter that you can see at the final product. And chemically decomposable ang homogeneous and heterogeneous. If it is decomposable, ang chemically decomposable, yes, that's a compound. And if it is not, then it's an element. We have another term, substances. It's a characterized or pure substances is can be the characteristic of pure substances, percentage composition, always the same, the sample throughout. Melt, boil, characteristic of temperature. Note, some compounds decompose before melting or boiling. And there are two types of pure substances: elements and compounds. We have been discussed about element. No, I already mentioned to you that what is element. And when we say element, not chemically decomposable into other element, no, it will never be happen. Properties do not vary. So element is element, it will not convert or decompose into other form of element. that is a very pure substance. And then for compounds, when elements is combination of two different elements, that is compound or molecular compound. Elements combined chemically into actually that's follow the law of definite proportion. No? How many hydrogen that you try to combine with oxygen to form water. So meaning to say there are two atom of hydrogen and one atom of oxygen combined. It's law of conservation of mass. Okay. So when two elements join together, the same element, that's a molecular element. And of course, element as mentioned that it's yes, writing first letter is capitalized, second letter is small letter, and it should be just symbol just like that. There are a lot of elements in the periodic table. Try to find out what are those. And very important, the allotropes. In allotrope, guys, one element can occur in several different form. That is allotrope. Meaning to say, ang oxygen, nag-exist na siya sa Earth in different form na ozone, O3 ang iyang kuan, napod kay oxygen O2, just like that. Kung napod kay oxygen lang, isa lang O. Oh, tulo ka klaseng oxygen mo na siyang allotrope. Ang isa kanang nascent oxygen, isa lang ka oxygen. Napod kay duha ka oxygen gas which is the one that we have utilized so that we could inhale and exhale, and the ozone layer O3. So there are tulo ka klaseng oxygen, si O1, O2, and O3, and those oxygen are different from each other, and that but the symbol oxygen is the same. So that is an allotrope. Again, when you say allotrope, isa ka element with that exists in different form. Oxygen ay O1, O2, O3, allotrope na siya ang tawag. And carbon also is, an allotrope of carbon is carbon 12 and 13. For example, na kay carbon graphite, kanang uling, ingredients for the pencil, na kay carbon in the form of diamond, no? So allotropes na sila, pareha sila carbon, pero lahi sila nga klase nga carbon, okay? So that is an allotrope. Mixtures characteristics, I mentioned already in the previous slide about two types of mixtures, the homogeneous mixture and the heterogeneous mixture. As a review, the heterogeneous mixture components not uniformly mix more than one phase, meaning to say nag-exist siya upon mixing duha ka states of matter. Ang makita nimo ang solid na bato or sand mixed in a water na ay duha ka states of matter na dito, ang sa solid ang sa liquid, so hetero na siya. Okay? And of course, sorry, may mga samukan. So that's an allotrope. I know mixture. Again, for heterogeneous mixture, once that you observe two different phases of matter upon mixing ang iyang product, makita nimo duha or tulo, that's heterogeneous. Halo-halo. When say halo-halo, na ay solid, na ay liquid, na ay pasas, na ay ions, na ay milk, etc. O na combination, that's heterogeneous. Oil and water. Ang heterogeneous mixture, it could have also both liquid. So nakay water and mantika. So duha ka different phases of liquid formed together, ay mixed together. So heterogeneous gyapon na siya kay duha man siya ka different liquid. Pwede po siya both solid, no? Mix nimo ang soil o sand. Hetero gyapon na siya, lahi man siya. And that's it. And for homogeneous components, uniformly mixed. For example, mix nimo ang two different matter, states of matter, ang asin, salt, and water. After mixing it, mawala si solid, and one phase of matter lang yung makita, only the liquid. And that is homogeneous mixture. Actually, both solid and liquid. Pwede po both solid, pwede po kag alloy, no? Sa combination, pwede kag aluminum and copper mixed together, na form siya alloy. So solid gyapon siya, pero two different solid imo gimix to form one solid state, no? And duha pod ka liquid, liquid ka nang mix together ang liquid of the pag i-mix mo sa duha ka liquid, ang ending niya is usa lang ka liquid, then that's homogeneous. And of course, both mixture of gases, hydrogen o dust and air, i-mix mo together, homogeneous siya, pero isa lang siya ka form of gas lang siya. That's So, meaning to say, both solid, both liquid, both gas, pag mix nimo niya, one phase lang inong makita, that's homogeneous. Pero kung duha ka different state or phases of matter, transition phases, then that's heterogeneous mixture. And of course, so na natin two types of mixture, uh, physical and chemical properties, exothermic and endothermic, and physical and chemical change. And now, for the separating mixture, there are many ways to separate the mixtures. Nag-mix ka, pag man i-separate na po nimo, no? Well, we do a separation of mixtures lab so you can learn about this. So, naa kay mga basic technique na ay filtration, mga muna yung mga separating mga mixtures, filtration, flotation, crystallization, extraction, distillation, chromatography, and evaporation. I-mix ni mong salt and water, muna siya ang one phase, then you want to regain, go back to get the amount of salt again. So you have to evaporate it, to heat it until boiling. So ma-evaporate na ang tanan liquid, and of course, mabilin is sodium chloride. So that's an evaporation, no? And of course, decantation also. Minsan decantation, gusto niyo i-separate ang sand out of the water. So you have to pour the water slowly so that ang sand or soil will retain at the bottom of your container. It will not disturb. So that's the decantation. Of course. So let's have a review for the matter. Ang matter, it is uniform throughout for no heterogeneous. Kay two states of matter man siya. And then, ang homogeneous kung one phase of matter. Kung may kag homogeneous, can it be separated? No? Kung may kag no, that's a pure substances. And of course, ang if yes, that's a homogeneous mixture. Ang pure substances, kung no, ganun siya, can it be decomposed into smaller substances or other substances? That's an element. Kung yes, that's a compound. Okay? So let's answer this practice. Classify the physical or chemical change. Mothballs vaporized in a closet. Are you familiar with mothballs? No, very odor, grabe yung odor, no, makasakit sa ilong. For insects, for killing insects, cockroach, impon nga predator. So mothball most likely benzene na siya, no, grabe kayo so yung smell could kill the other insects. So mag-vaporize lang siya, mag-volatilize. So that's a physical change. Hydrofluoric acid attacks glass and it is used to make etchings. So naima scratches using hydrofluoric acid. There's a chemical change because when you try to attack that in a different composition of glass, that's chemical change na siya. Calcium chloride lowers freezing temperature of water. So it's more on freezing temperature. That's a physical change, no? I-freeze lang niya maayo. I-lower lang niya minuto say para dili siya mo freeze easily. And an antacid table fizzes of fizzing. So meaning to say nagbubble siya. Ang antacid, that's a chemical change. There's something bubbles happening, like chemical reaction. And next, flashlight battery corrodes. Ang flashlight batteries, that's a chemical change because you utilize the battery chemically for that. That's why ni corrode siya, then ni dim ang iyang light. There's something chemical changes that happening. Whole milk curdles as a vinegar is added to that one, no? So that's chemical change again. Excuse me. Boiling water is physical change. Okay. Well, that's it. That's the end of my presentation for matter and its property. So after this video, please take note with this video. Get paper and pen for the note taking because and make this as your outline to look for another video similar to the topic because we will have a long quiz every Friday. So since the discussion has been done, we will have a long quiz. Okay? So kung nagustuhan niyo ang aking video or even not one, feel free to subscribe. Click the notification bell, subscribe to my channel, and of course, make a comment, no? If you have something I mentioned wrongly or you have something to add or to make any correction, I am very pleased and I am very welcoming those person mag-comment, no? So, again, please wait for my next video for the week 2, that is measurement. So, try to review about significant figures, scientific notations, physical quantity, and of course, accuracy and precision, because that is our content and topic for the week 2. Okay? So, bye for now, guys, and please study hard. And thank you so much, and God bless us all.